In our opening video for this series, we will talk about Simple Mail Transfer Protocol, SMTP, which is a text-based standard defined in RFC 5321 that describes all requirements and all message formats for electronic mail communication. Electronic mail communication is abbreviated as email or e-mail. And both of these forms are grammatically correct, but since first of them is commonly used across all SMTP related RFCs, this is what I will be also using throughout this series. SMTP was implemented using that regular client-server architecture, which means that one of the devices involved in the communication is going to be listening for incoming connection. This is going to make our server portion, and in case of SMTP, it is going to be specifically TCP port 25 to listen to the client packets. And then the client is going to be initiating a session by sending packets to TCP port 25. The client portion is sometimes referred to as Mail User Agent, MUA, or Mail Transfer Agent, MTA, where the difference here is that MUA is talking about your regular email software application, like for example, Microsoft Outlook, or maybe some sort of a web-based client. And this application is only capable of sending emails to a SMTP server, which is what makes Mail Transfer Agent. And the difference between the two is that SMTP server is not only able to listen for the incoming emails generated by our email client, but it is also able to relay those messages to other SMTP servers. So we can say that the client, our Outlook, our web-based client, is only capable of sending messages. Like you create a message, you open up the client, you specify a recipient, you specify subject of the message, then the message body, and this is what's then sent to our server. So this is the actual message. And now the server itself is not capable of creating new messages. It can either listen for those messages generated by our applications or maybe messages relayed by other servers, or it can simply act as a relay. So what I get from my Outlook, I'm gonna then send to another SMTP server, possibly one that is responsible for ultimate processing of that message. SMTP devices use a pretty simple method of exchanging information. Our client is going to be initiating a session by sending some commands to the server, and the server is supposed to reply to each of the commands with a message containing a code and optionally some additional text describing the response. A single exchange of commands and responses to forward a single email message is also known as SMTP conversation or transaction. So similar to web transactions, we can have multiple SMTP conversations or transactions seen within a single SMTP session. SMTP session acts as a channel for exchanging data between a client and server. And this channel is going to be up until a client or server eventually wants to stop communication. For instance, like when the client sends the quit command. And most of those commands and also some of the response codes, we will discuss this stuff later in this session. Now notice here that SMTP itself is never used to pull or just download emails. It is only used for sending or relaying messages from one server to another. In order to fetch or just download messages to the client, the application will have to connect using different protocols, like for example POP3 or IMAP. These two are commonly used for pulling emails, but not for sending messages. Few words about email structure. Every single email message consists of two main portions. We have the envelope and we have the data portion. Now, the envelope is what our SMTP server uses to forward or simply deliver the message to the destination, as we will see in just a moment, domain. And this information is actually not visible by the client's email software. It's only going to be the data what the client application will eventually see and display to the user. And the data portion consists of the header and then the body, or just the actual message, where header is talking about multiple header fields, like for example subject, like to, like from, and then the body makes the actual information that we want to send to the recipient, including the optional attachments. So from a high-level perspective, the actual message is going to look like that. We will have the envelope, which is what defines our email sender and our recipient or potentially recipients. And this is going to be kind of like prepended to the data, which is a bunch of header fields, and then the actual content of the message. And this information here is being used by SMTP devices, SMTP servers, to forward the message. Specifically, it's going to be the recipient portion. The sender is optional, but the recipient must be always here because the receiving device must know how to forward the message, where to forward it to. And this information is going to be eventually stripped off before this portion is going to be downloaded by the client. So the client, like your Outlook, will never see the envelope. This is only used by SMTP servers. Okay, I said that the data's header portion consists of multiple header fields. Some of those fields are mandatory and some are not. Like the from and date fields, these two are mandatory. It means that they will always exist in a message. A date is simply acting as a timestamp. And from, this is something that is going to be populated by your email application. And even if it is not, SMTP server is going to copy the envelope sender and put it into this header field. So this information is always there in a message. And by the way, this is something that spammers commonly use to send unwanted messages. Remember that the envelope is technically unrelated to the data, the portion of a message. So the envelope sender doesn't necessarily have to match the from header field. You can send a message, let's say from user1 at example.com, but the recipient of the message is going to see a different sender in this from header field. And then a few other fields that are optional. It is going to be to, a subject, and carbon copy. So to is optional. It's technically not needed. Remember that it's the envelope, the recipient portion, what is being used to forward the message. Probably the most important thing to remember about SMTP is how emails are delivered, which is always based on the destination domain. So for example, when you send an email to kate@cisco.com or john@cisco.com or someone@cisco.com, this first portion has nothing to do with email forwarding. It's only going to be the domain, what is being used by the SMTP software to forward and eventually deliver the message to the final SMTP server. And now specifically, the process is heavily relying on DNS, exactly like with web communication. Like when you type in a URL to a browser, you say you want to go to www.cisco.com. We know that what's going to happen on the backend is going to be that name resolution performed by the browser's resolver we will send a request looking for an IP address associated with www.cisco.com, and only when we get the reply and we know the right IP address, we will be able to form a packet and send it to the final destination. A similar thing is going to happen here. When your email application configured with an IP address of a SMTP server sends a message to this server, it is going to cause the server to perform name resolution on the destination domain from the envelope recipient, looking for information about the email server responsible for this particular domain. And this is the main difference from a normal web resolution. We will not be looking for the A record, at least not in this step. What we will look instead is going to be the MX mail exchange record. Okay, so assuming that your domain is capable of receiving email messages, it should be normally configured with at least one MX record, which consists of two portions. We've got the priority and we've got the name of our email server. And the reason that we have this priority is that we can define multiple entries for redundancy or even a load balancing. And it's going to be always the lowest number what will be preferred. If numbers are the same, emails will be load balanced using the round robin algorithm. And maybe just to show you this in action, I'm going to use NSLOOKUP, and I will set the type of the request to MX. So instead of trying to find an IP address, I'm trying to find name of the mail server for cisco.com. This is going to be my domain in question, like what we saw here. We want to send an email to Kate at Cisco. So we will try to forward that message based on the cisco.com domain. And we see that in case of Cisco, this is real information. What I got here, they are configured with 3 email servers. And each of those servers uses a different priority value. So 10 is going to be the most preferred number. If this box is down, we will try this one with 20 and finally fall back to the third one. Okay, so this is a portion 1 of the resolution. At this step, we only get a name. Now, in the second step, SMTP server will try to figure out what's the IP address of this particular SMTP server it got in the first step. So I'm going to set the type to be now A, which stands for address. And we will try to figure out what's the address of this email server. It's going to be that number. So at this point, we would open a TCP session. We would initiate a TCP session acting as a client to this SMTP server, in this case acting as a server portion of the session. It would be a connection built over TCP port 25. And assuming that the handshake is finished and the session is up, we would then prepare the SMTP channel, SMTP session, allowing the devices to exchange a series of commands and responses. Okay, some domains, they don't adhere to the RFC. And for this special case, it is possible to use the regular A record associated with the domain to simply use it as a fallback. So whenever your SMTP server doesn't get any MX record for the destination domain, it is going to use this information and connect to the IP address returned in this step to deliver the message. In our case, we could take a look at that just by saying NSLOOKUP for cisco.com. It should give me that regular A record, which is this number. So this is going to act as a fallback, like if these 3 devices are not available, or simply if this information is not in place. We will now quickly go over a few more important SMTP commands as documented in RFC 3321. So it is going to be the hello command, or possibly extended hello, EHLO. This extended command, this is something that is technically defined in a separate RFC called enhanced or just extended SMTP. This additional document describes a set of extensions, a set of new commands that allow you, for example, to authenticate a connection or maybe use TLS. But this stuff is now included in this latest specification 5321. So we can also use this EHLO command instead of the original hello. Now, technically speaking, it doesn't really matter which of these two you're gonna use, because most of the current SMTP servers, they know the extensions. So this would be only needed if you wanted to use some of the extended commands. If you plan to use the regular one, you can use any of these two. It's just to introduce the client to the server. It's like a client greeting, what these commands are used for. Optional, you can also provide the domain to identify yourself to the server. Okay, another important one is going to be mail from command. This is what we use to populate the envelope sender. And then received to is going to be used to populate the envelope recipient. So these two commands, this is how we build our envelope, which is used for forwarding. Then the data command, this is how we signal to the server that we want to continue with the header fields, and then the message body and possibly some of the attachments. So this portion is going to be seen by the client. Start TLS, optional if you want to use TLS to encrypt the session. And finally, quit is how we finish the conversation. SMTP response codes, they take a 3-digit format, same as HTTP. And in reality, it is only going to be this first digit what's most important. So whenever you see a response starting with 2 or 3, it generally means that the command was processed successfully. Whenever you see a response starting with 4 or 5, it means that we have a problem. And now some of the common response codes, so ideally we want to see 250 for a regular command. It means that it was accepted without any issues. 354, example of a successful command. In this case, the server is waiting for some additional data. This is another one you would normally want to see during conversation. 421 and 52, we have a problem at the connection or recipient level. Like the connection level, this is all about the IP address of the connecting SMTP server, like maybe when it's sent too many messages. Where the recipient level is an individual email account. Like we got too many messages to a single user. And that type of a problem is generally referred to as soft bounce, because we tell the client that the message is not delivered at that point, but we will try to deliver it at a later stage. So it doesn't necessarily mean that the message is going to be eventually dropped. Where with messages starting with 5, this is referred to as hard bounces. It means that there was a serious problem that prevented us from delivering a message, and the message was eventually dropped. Like, for example, when the recipient account, it doesn't exist in our domain. And to finish, a simple example of a full SMTP conversation. So we see that the connection is, SMTP session is established at that point. The server introduces to the client. Then it's going to be the client what introduces to the server. And the command was successfully processed. This is our envelope sender. It's going to be this address, what's going to make the envelope sender. The command was successfully processed. This is going to make the envelope recipient. So our message destination, and this information is going to be used for forwarding of the message. The command was also successfully processed. And next we signal to the server that is going to be the message that is going to follow. We are using the data command. We can optionally define some of the header fields, like in this case, we see a subject. A header field always ends with a colon. Then we specify our message, and then to finish the email, you simply put a dot in a single line. It says accepted, and then quit means that we want to terminate the SMTP and also TCP connection.